All right, welcome listeners. This is George O from AnoTalk, all things anodizing. And I am here, I guess I should introduce myself first. I always forget to introduce myself properly. I never really think about myself because I just have so little ego. But
You're a giver. You're a giver, Dr.
I am a
Spoken
giver.
like someone who doesn't have an ego.
Right? So my name is George O. I am a research and development chemist at Quaker Houghton out in sunny Alpharetta, where, it's December here, so things are getting a little bit chilly, but the weather's still pretty enjoyable. So with me, I have my two co-hosts. Let's go with Tej first.
Thanks, George. My name is Pinakin Patel. I'm a director at Techevon. I'm based out of our Chicago metropolitan location. To my neighbor to the north is going to be joining us, Mark Spencer. Why don't you tell us what's going on up in Minnesota?
Well, thank you, Tej. It's Minnesota. Very good. Very nice. It's a lovely 1 degree, and we're supposed to get 12 inches of snow here tomorrow. We're looking forward to that, so we can come down to Chicago, and then we can laugh at you guys. But
exactly.
Hey, our Vikings are like 13-2 or something like that. So all you got to say is,
even a broken clock is right twice a day.
You'll be welcome up there, Tej. Yeah. So anyway, Mark Spencer, sales manager at AaCron Anodizing up here in Plymouth, and glad to be on today. We're excited about this next subject, aren't we, fellas and lady?
Yes.
Yeah.
Okay, so today we are going to talk about anodizing versus paint. I'm trying to do a Minnesota accent, and I know it's atrocious. I apologize.
That was a valiant attempt, George.
So, we actually have someone who just gave a talk on this. So, Tej, you actually at the last Aluminum Anodizers Council meeting that was Kansas City, right?
It was, yes.
Delicious food. I'm not going to say we should go back there soon, but it was a nice place to go.
It was good.
But you gave a talk about anodizing versus paint and sort of the pros and cons and when you do one versus the other and what they look like. So let's sort of like chit chat about that. Like let's jump right into it.
I'm gonna have Pinakin here too. He's our special guest subject matter expert as it relates to some of this. So that way I don't misspeak. He's my legal counsel in this podcast. Because Mark knows I tend to oversell things, right, Mark?
Oh, I think you're rather conservative, but that's okay. That's okay.
But yeah, let's get into it. There's a lot of smart people.
Before we jump right in, Tej, if you don't mind, let's reintroduce Pinakin, because the last time we spoke to him was many months ago. Sharing with us that he has a victory garden down there in South Carolina. So, Pinakin, we're in the fall season. What did you grow this year?
Well, all I can do is I got about 25 different Japanese maples.
Okay. Oh, wow.
Yeah, it's well, see, I've got 2 or 3 that I know they'll make it through this cold spell. We'll find out.
Fingers crossed.
Yeah, that's right. But no, my name is Pinakin Patel. I'm with Techevon, and we supply dyes and chemicals to the anodizing industry. So our goal is to try to promote anodizing as a good finish for architectural, and so we've done extensive work on trying to understand how the anodic coating stacks up to organic coatings, and we have some pretty interesting data, which I'm sure Tej will share with you. And hopefully that's of value to our customers.
Yeah, so let's jump right into it. I mean, you think about anodizing and you think about paint. There are 2 things that you slap on a building to make it look good and be like fun colors and protect the metal or the surface from the elements. But what are the differences, Tej?
Yeah, so the fundamental differences in the sense of a paint, that is a top coat that's being put on top of the base metal, which is aluminum. In the case of anodizing, we're actually converting that base metal into aluminum oxide. That aluminum oxide then can be colored in a myriad of different ways. You can use electrolytic coloring, you can use organic dyeing, you could use inorganic dyeing in the form of a gold dye. but it's actually inside the coating, and the coating's integrity is held within that aluminum oxide layer, which is then sealed. So that's the first difference. You're creating something from the metal that is sealed, and that anodized coating, if sealed correctly, can withstand a lot of different types of environmental stress, whether it be heat, UV light, high pH, whereas a paint product being a top coat, when exposed to an environmental stress, heat, UV light, chemicals, that actual organic paint is being attacked. It is in fact the coating. So it could actually be damaged. So that's I think the first kind of misnomer and kind of normalization I think we need to do is to understand that a paint is basically a top coat, and anodizing is actually within the metal.
Okay. So and you talked a little bit about like the pros of anodizing and the cons of paint, but like what are the pluses of paint?
Yeah, so I mean, look, there's a reason why paint is so popular. You can go to Home Depot, you can take a piece of paper, and the person at Home Depot or Lowe's or Menards or whatever hardware store you're going to can put a spectral colorimeter gun on it and come up with a color match. And that color match can be glossy, matte, satin. There's all kinds of fun different things you can argue with your wife about to decorate the kitchen with. So that flexibility, that availability makes it very popular. Access to a paint product, all of that stuff. Now, within the paint category, there are a myriad of different options. I mentioned just your typical, residential paint. There's powder coating. Within powder coating, there's a myriad of other types of powder coats. I don't pretend to know everything about them. Varying ranges of quality. PVDF. There have been breakthroughs recently with high quality. Kynar is a brand name that is used.
Oh, yeah.
It can hold up to 25, 30 years of external exposure. So there is a range or a continuum among paints, but the benefit of a paint is you get a variety of different color options. The application doesn't require a full anodizing line, so you can do it in a smaller space. And there's actually quite a bit of powder coating capacity out there. It's a fairly prolific finish as it relates to that. Those would be kind of the general reasons around why paint is so popular.
Okay, so I mean, like, would you say like if you're, doing like things on a very small scale, like you just shouldn't think about anodizing, or it should just?
Yeah, so it all depends, right? The paint, a painted product is going to have a certain cosmetic look. There is a reason why certain applications call for anodizing. It's a richer look. It has visual appeal. That's why people aren't painting MacBooks. They're not painting your cell phone. They're not painting keyboards. Cars are painted, but many of the components within them are anodized, right? Now, not to say that won't change, but there is a significant benefit of using the visual appeal of an anodized coating.
That makes me wonder like why someone hasn't just like done some kind of like art installation where they take a house and instead of painting it, they just cover it in a bunch of like old iPhones or something like that. So it's like all anodized.
Recycled it, yeah, exactly. Well, the reason for that is it probably won't pass UV stability because the individuals who are anodizing iPhones may not have the best seal quality.
Ooh,
they don't do what they do up in AaCron, George. They don't have that level of robust sealing.
Sick burn. Wow. Shots fired, Tage. Oh my gosh. But you mentioned something interesting, like actually, Mark, like wasn't there a huge project that AaCron just did, like for this like huge, gorgeous anodized finished building?
Well, we've had several large projects out there. Our most recent one was a finish we developed up here for the SoFi Stadium out in Los Angeles. And when you hear the architect talk about why he specified anodizing, because of the depth, and as Tage mentioned earlier, the richness of the finish itself. It was a frost finish that we developed up here. And when the sun reflects, whether it's the morning sun or the afternoon, evening sun, it just comes off that aluminum. And he was just tickled pink of the, that wouldn't be that pink color that is named after Tage, but he was just very pleased with how the anodic coating, how the finish worked in that particular environment. So
Gosh.
that's absolutely. And then we just did a green for an architect out in Seattle, and that's going to be interesting. Can't wait till we get some of those pictures up on the website. And it's interesting because we're starting to see more and more architects specifying colored anodize than we have previously.
So why is that happening? Why are people suddenly starting to specify anodize instead of paint?
Well, I wish you could say we're riding the wave, but it's just starting. We're at the tipping point, maybe.
Okay.
More architects, but there's several knocks on anodizing. You know, one of the things with paint is that when you paint it, you can, in some respects, get a little more color consistency because of the opaqueness of the paint as you can with anodizing. Is it the fault of the anodic coating? No. You know, if we get what's let's just say 6063 alloy, there can be certain alloying constituents that can have an impact on the color of the anodic coating, right? More iron, more copper, silica, magnesium, all those things have an impact. It's not that the anodic coating is going to color differently and say, I'm going to take this piece of aluminum and build the anodic coating this color, and on the same rack, another piece is going to color differently. Typically, that's a metallurgical issue than anything else.
Yeah.
So one of the knocks we have with anodizing in the architectural industry is just color uniformity.
Okay. And yeah, that's just something that, like, I guess designers and specifiers have sort of figured out how to work around, I guess, right?
Yes.
Yeah.
And there's some AMA specifications out there that really help as well. It's just that if we want to really get in paint's back pocket, I think we need, as an industry, to work together to figure out how we can tighten up the color ranges. And that's usually on the metal side.
Yes. Speaking of Aluminum Architectural Manufacturers Association specifications. Oh, that's a mouthful. You know, we've got like color matching and other specs, but we've also got things like durability and corrosion resistance. And, you know, what are the differences between paint and anodizing on that front?
I'll take a shot at that. So as I mentioned earlier, right, the paint being a top coat, if that top coat is penetrated or damaged, there is a risk for filiform corrosion. The benefit of the anodized coating, since it's a ceramic and since it's actually converting the aluminum to aluminum oxide, is abrasion doesn't cause the filiform corrosion. Now, that's a big reason why automotive pistons are anodized aluminum. They can withstand high abrasion environments. So that's one benefit. I think the other benefit is electrical conductivity. Obviously, again, when you go to the base metal and you're damaging that top coat, that base aluminum is now exposed, whereas the anodized coating is an insulator, right? So that's a final benefit. And I think the final piece, and this is kind of some of the work that we've done here at Techevon, there was a perspective that organic or powder coating paint had a better type of visual appeal when exposed to UV light. And the data that we've seen, when an anodized coating is sealed correctly and follows certain specifications of coating thickness, coating density, dye times, seal times, it actually performs equivalent or better than the top type of powder coating out there, for example, Kynar. The misnomer is when visual measurements are taken, the powder coating or the paint finish fades uniformly. Because it fades and shifts uniformly, it's difficult to notice variation because it's consistent variation. In the anodized coating, you don't have that luxury necessarily, right? So in the case of that, you don't have the ability to Mark's point, get the same anodic coating properties at every square inch of that panel or that piece of metal.
Yeah.
So in previous applications, you saw that uneven finish, and that resulted in quote unquote poor quality. Turns out the big difference with powder coating and anodizing is powder coating has a significant loss in gloss. So when you put that powder coating part out in the UV light for extended periods of time, and you compare that to a freshly powder coated part, it is a night and day difference. And I don't think the industry does a very good job of explaining that. And there may be a reason why they don't explain it. But from a visual color difference, in my opinion, the gloss lost in a powder coating finish is much more evident and visually noticeable than a organic or a two-step part that has some slight fading based on that similar type of exposure. So there's a little bit of a misnomer there, in my opinion. Now, Pinakin, you've done some of the work. You may have some more comments on that.
All right. So I think, first of all, the fundamental reason products corrode is because you have two dissimilar metals that are electrically connected and have a source of oxygen. So when you anodize, you put the color into the coating. If you seal the coating well, you have blocked any oxygen from getting to the coloring media, the dye or electrolyte color or whatever. Now, the dye itself can break down with ultraviolet light. Some dyes do. But if you have a dye that does not break down with ultraviolet light and it's sealed well, there is no possibility for the color to change or whatever. And the spec, unfortunately, I'm not very familiar with AMA, if AMA has a gloss spec, but the requirement typically is a delta E of 5. Every one of these failures, and we checked PVDF, every one of those coatings we checked, they all had a dramatic visual difference to the eye, but the delta E's were all within the 5, with the exception of few. Almost all of them were within the 5 units of deviation. So basically, fundamentally, what's happening in the organic coatings, in my opinion, is the pigment is surviving the UV. And that's why you're not seeing that. But the actual chemistry, epoxy, PVDF, acrylic, urethane, that is breaking down with the UV and the atmospheric corrosion. And that is causing the gloss to change, which changes the appearance of the parts. So, and there is no way to stop that. All paints will get degraded because they are top coats, and the organic that is used to top coat it is going to break down with ultraviolet light. There's no way to stop that, which is a fundamental difference between anodizing and that. Anodizing is an inorganic coating. There's no degradation as a result of ultraviolet light to the anodic coating. The anodic coating in and of itself will never be degraded by ultraviolet light. And that's the fundamental difference, I think, between anodizing and that. Now, if we can offer colors that are durable, I think we have it licked. I think we have a very good situation there.
Yeah, and then there's also the other issue that you mentioned of like, we've got these specifications that say, a delta E is a 5 is going to be sort of the benchmark. And the delta E of 5 is such an imperfect measure of change, right? Like it doesn't take into account gloss. Delta E is a combination of like the delta, if you're using like the LAB scale, like, or L star, A star, B star rather, it's a difference of all of those. And, like a difference of 2 on the L axis is completely different from a difference of 2 on the A or B axis, right? The visual difference is just night and day. So yeah, that's just another thing. So here's a question that I wonder, as someone who's like relatively inexperienced in the industry and doesn't actually try to sell people on anodized finishes per se. Is there someone out there that has actually found someone who said, I am going to put a painted surface on this building or this project, and somehow was convinced into switching to anodize?
Mark.
Mark, that would be your question.
That's Mark's wheelhouse. That's his job. George, that's the job description Mark signed up for.
That's a
Please
great
change people from buying paints to anodizing.
We're still waiting to find that project where it was going down the path of paint, and then they decided to go anodize.
So here's the question, like, where would you sort of make that happen, I guess, if we were thinking about it? Because it's like, do you talk to the designers? Do you talk to the architects? Do you talk to, like, I don't know, the public, and just be like, hey guys, anodizing is really cool. What if your building were an anodized building instead of a painted, high rise or what have you?
Right. So typically when we're going down that path, those are what a lunch and learns with architects, right? Getting in front of them to promote the anodic coating itself, as well as panel manufacturers. Because over the years, anodizing has, in some respects, gotten a black eye in the architectural many years ago with colors fading and things like that. So we've had to overcome that stigma. Also, with color variation, that there's been just that's another black eye that the architect's looking for perfect color and a panel going against panel, and there's sometimes where that's not going to happen, and that's where you find architects that like that slight variation.
Okay.
Well. So Doc O, there's not a now maybe someone else around here is familiar, or maybe our listeners might be able to email us and share that, right? That's mail@anodizing.org.
That's correct.
Yep. Oh, baby. All right. So there we go. And, maybe they could share with us those stories, because we're all in this together. If we could, take some, we were at a customer the other day, and it's just like 95% of what they do is paint and 5% is anodize. And it's just like, we got to reverse that trend. Pinakin, I wanted to follow up on filiform corrosion, if you don't mind.
Yep, sure.
Okay. And why wouldn't it, if you're just having panels, let's say 6 by 12, 6 by 16 feet panels that are going to get punched and parts made out of that, right? So if it was painted, where at the edge of the part, wouldn't you have filiform corrosion between the aluminum and the part, where if it was anodized, you wouldn't have it?
Right. So I don't know that it's common to punch, but normally with anodizing, you can fab afterwards, potentially. But you could not do that with paints, because absolutely, if you have one scratch in the paint, and then the filiform corrosion is amazing. It's amazing the difference between how the coatings will fail in the filiform corrosion compared to the other, to anodic coating. That's probably anodizing's biggest advantage, is this filiform corrosion. There is no filiform corrosion with anodizing.
And okay, so let's say they don't punch, but let's say they cut the parts to length, right? So you get these panels, you're cutting them down and then bending them. Now with bending, you bend the anodic coating, what are you going to get?
Well, you'll get crazing, but you will not get blistering. So the crazing in and of itself does not impair the performance of the coating. It's visually not attractive, but from a corrosion standpoint, there is no problem with corrosion. The coating is still intact. It just has relieved some stress, and it shows in the form of crazing. I mean, there's an awful lot of energy that's put in to make that coating, and that energy needs to be relieved. It does get relieved sometimes, be it heat or bending or whatever. And when that energy is released, it shows up as a crazing. But the properties of that coating will not fail at that point. In fact, it's not common. It's not common to check anodizing with a bent part in a salt spray, whereas it's pretty common to do that in plating and painting. People will bend a part to check it for salt spray, and it will fail in those areas. Anodizing is not a common thing because it doesn't fail in those areas.
Well, and Mark, there's some things you can do on crazing too around the coating properties to mitigate that.
Right. Although at the end, right, that's true.
We just so an information, we just did some testing for a customer, and we got 96 hours of cast test passing on a copper electrolytically colored copper bath. That's unheard of. To give you perspective, the GM spec is 9 hours for anodizing.
Oh, wow.
Yeah, it's anodic coating, when it comes to, when you do it right and all, it's phenomenal to any kind of accelerated corrosion like cast or whatever. It's paints and all will not even come close to it in that performance.
So, we've talked about sort of like the downsides of anodizing. We've got like, the color matching isn't necessarily perfect. The color consistency across a panel isn't necessarily like 100% like it is paint. Like, could we potentially get there, like with like engineering controls or something else?
I think Tej talked about that in his paper, because years ago when people anodized, it was 16 volts, 40 minutes, 16 volts, 40 minutes, regardless of the load size or whatever. And you know what happens when you have a different load size, it's a different resistance and you get a different property. Today, there is technology out there where you can, with an automatic controller, you can tell the coating or tell the load that you want so much current density, so much thickness, and you'll get it. So there's a lot of advances that are made today as it relates to providing consistent current to the load, irrespective of the area or the size of the load or whatever. So with that, and also the methods to evaluate dyes and the methods to check electrolytic color have gone so much better today than they used to be when in the early stages. So because we have a lot more control over the process than we ever had, and 15, 20 years ago, we didn't have this kind of control in anodizing. We have that. So our ability to produce a coating with very high degree of consistency from an anodizing perspective is there. What we don't control is the metal. And the one he talked about is the uneven. When anodizing fades, it doesn't fade evenly. And so it's very easily perceived. And that, I think, a lot is because of the metallurgy of not the anodizing itself.
Yeah, and that's probably only going to get worse with the move towards like secondary billet and more recycled aluminum. But so you mentioned all these like improvements that we have for processing and getting consistent current. Like, is that something everyone has? Is it something everyone could have easily?
Well, easily is a loaded question, but technologically it's achievable. The cost, I don't think, is astronomical. I think you can cost justify it. A lot of companies have that ability. Some of the high-end companies that value the quality have installed them. But these automatic controls are not expensive. So
the automatic control is just a matter of finding the supplier of like the rectifier or what have you who has that.
Yeah.
Okay, that seems easy enough, honestly.
Yeah, that's easy enough, and if it's not cost prohibitive in that regard.
Yeah. Okay, so I mean, we solved one of the problems. It sounds like if everyone actually adopts it, I guess.
Yeah, and then again, the methods to check the color quality and whatnot. I mean, I know anodizers don't like to be subjected to LAB values, but a lot of customers are doing LAB testing in their plants. So a lot of this is awareness. I think when you leave yourself open to qualitative analysis, is this good enough? I think the tendency to slack quality is much higher. But when you put, even internally, when you say, I don't want anything less than delta E of 3, it puts a lot more pressure on the people to do a more thorough job of what they're doing, I think. So I think some of that is also playing into the game, which wasn't the case before. Before it was, you cannot measure color, so we just got to go by the eye. This looks okay. And I think some of those things are going away in the industry. The good anodizers are not doing that anymore.
Yeah.
So I think that's helping some.
Okay. There's one more thing. This is kind of a complete tangent, and this is probably a question for Mark more than anyone else. So we've got dyes, we've got electrolytic color. What's like something weird and cool that you would like to see as like an anodized finish?
Oh, that's a great question.
We only have 15 minutes left in this podcast, Mark, just so you know.
There's some things that are going on with aged steel, with the corrosion on steel. There's some things that are going on with copper, in which they're aging it in an accelerated fashion under controlled conditions, but it's given the architect new finishes. And so, what we're looking for is something that's going to give it a muddled look or have some inconsistencies within the panel itself.
So like some kind of like super industrial look or something like that?
Yeah.
Okay.
Yeah. And you go by some new buildings today, and they have this aged steel. It's aged steel. It's corroded. The steel's corroded.
So uneven color with some corrosion. Is that what you're asking for?
It's like the opposite of what we're trying to do, right?
Right. Right. I was asked to get some panels, and they're here at AaCron when anyone wants to come up and take a look at what we'd like to. There are some European anodizers out there doing some really neat things, and maybe some Australian anodizers as well, as far as color goes for the architectural market.
Maybe we should have them on the podcast, huh?
We should invite them over.
Yeah, you know what? It's we can do it all remotely. Although honestly, I kind of would. You know, why don't we all take a trip to Australia and do it in person?
Good idea.
We've got the budget for that, right?
Yeah. Hey, Dr. O, something else that's a knock though on anodizing is touch up, right? So we haven't talked about paint. So the high performance paints, 2605s, are typically a softer paint. Would you agree there, Pinakin?
Yep, I'm here.
Okay, yeah. So and so it is going to scratch easier than anodizing. The issue is that paints you can touch up with paint kits that are formulated to match that color. Anodizing, when we scratch it, now it takes more effort to scratch the anodic coating, but that's another knock that's on us, is that the touch up of dark bronze or something.
So is there no way to fix that, or?
Well, I can think of one way to fix it.
Take it off the building.
In plating they have those pencil platers. You could apply those anodically. I've done some work on anodizing. It works actually quite well. You're not going to get a perfect anodizing, but you'll get enough so it'll be dyeable and colorable. It won't have the same density or whatever, but you will have enough anodic coating to be able to do something to it.
That seems good enough, honestly.
Yeah. Well, we should have some clear on it, correct? You'd have a tough time getting two-step.
I mean, you might be able to. Like, there's all sorts of portable plating sort of technologies out there. Right?
It's quite common in plating. It's quite common and done very effectively actually. They only put about 3/10. You can only put about 2 or 3/10 with it, but that's fine. If you can do that much and then dye it, you should be fine.
Yeah. And then I guess the question is, how do you seal it? Do you just hit it with a little steam gun or something?
No, just touch it up every 2 or 3 years. Don't seal it. When
that works.
Just touch it up again.
Yeah. And business for the touch-up anodizers, right?
Yep. That would be a potential. The reason I know this is GM. At one time, I'd looked at anodizing anodizing the bumpers and the entire cars. They did a bunch of testing. They liked it. The advantage of anodizing, of course, is, and I don't know if people appreciate that, the weight of an anodized piece of anodized component is significantly less than a painted componment.
Oh, I'm sure.
So like a plane. So if you have a plane, you're better off not anodizing. You're better off not painting it, because paint puts a lot of weight on that thing.
Oh yeah.
And so that's another advantage anodizing has, that there is a weight reduction, and when you put anodizing versus any other paint, typically.
Yeah, that's going to be big.
So,
all right. Well, I don't know. Is there anything else to talk about with paint and stuff like that? I'm sure we could talk about a billion things, but this might be a good place to call this particular discussion.
Yeah, I mean, hopefully people send some questions in, and we can continue it at our next Q&A podcast.
Yeah. So once again, that's mail@anodizing.org. M as in monkey, A as in, I'm terrible at this, A as in Abigail, I as in industrious, and L as in loofah. Does that work? That works, right? Yeah.
You can use the NATO alphabet next time.
I can never remember the NATO alphabet. I wish I could, because that would make this so much easier. But yeah, this has been George O, Tej Patel, Mark Spencer with special guest Pinakin Patel, and we look forward to hearing from you. And next time we hope to see you on Ano Talk, all things.